This is lesson 9.1 and the topics for this lesson are going to be electromagnetic radiation, EMR, electromagnetic spectrum, wavelength, ultraviolet, visible light, infrared. Also, we are going to be talking about satellites, spectral bands, pixel resolution, spectral signatures, spatial resolution, spectral resolution, radiometric resolution, temporal resolution, and we are going to be using Sentinel 2 as example. At the end, we are going to make some band compositions with Sentinel 2. The websites we are going to visit today are going to be Wikipedia and Sentinel Hub. Hello everybody, this is lesson 9 and today we are going to be talking about satellite images and how we can use these images for our projects. But first, let's go to watch a 5 minutes introduction. Electromagnetic radiation can come, for example, from solar radiation reflected by the things like soil, plants, water, etc. Also can come from terrestrial radiation emitted by the things, and also it can come from the radiation emitted by the sensors and reflected by the things. Every one of these ones has a different wavelength. For example, in the first case, the visible light and infrared. For the second case, the wavelength is going to be the thermal infrared. And for the last one, good example is going to be the LiDAR technology and radar. The electromagnetic spectrum is the range of frequencies of electromagnetic radiation and their respective wavelength and photon energies. But what kind of wavelength we can use for GIS applications? For example, we can use ultraviolet. The applications could be different ones, like for geology, atmosphere, marine pollution, and etc. Other one is going to be the visible light. Visible light is the only part of the electromagnetic spectrum perceptible by the human eye, and the applications could be geology, forestry, water, urban applications. Okay. Other wavelength, very important, it's the infrared. We can make the difference between near infrared, mid infrared, and far infrared. The far infrared is known as thermal infrared, and the applications for this one, it's the temperature. Let's go to see how the radiation acts when it hits on the surface. Part of the radiation is absorbed by the atmosphere, but other part gets the surface of the Earth and then could be reflected, could be transmitted, and also could be absorbed. Okay, but also the surface and the objects on the surface can emit energy. When the electromagnetic radiation hits the Earth's surface, part of the energy is reflected, another part is transmitted, and another part is absorbed. After the energy is absorbed, is transformed in other form of energy and later can be emitted also. When the energy is transmitted, pass from one medium to another medium, and then also could be reflective. Satellites have sensors that can capture the energy reflected and or emitted by the surface and objects. Sensors can detect a range of wavelength and specific frequencies. Then we have the spectral bands. Every satellite has different spectral bands. For example, in this case, this is Landsat 7, we have all these bands. You have the pixel resolution and the range of the wavelength. For example, for Sentinel 2, we have 12 different bands, and every band can capture a specific wavelength, and also the resolutions are different for every band. The last one is going to be a spot 5. We have these bands there on the pixel resolution and the spectral bands, but we have more satellites. Each substance object on the surface of the Earth reflects energy in a unique way. We can call this phenomenon a spectral signature. Then, if you know the spectral signatures, you can know what substance object is reflecting the energy. Then you can create the cartography from remote sensing. Spectral signatures, as you can see on the graphic, it is represented by the percent of reflectance and wavelength. Then, for example, in this case, we have the spectral signature for vegetation in general, dry soil and wet soil, and you can see the wavelength is a different one for every case. In this other example, we can talk about the geology, what kind of soil we have, for example, sandstone, shale, limestone, according to the reflectance and the wavelength. After this short introduction, I would like to talk about 4 different concepts, okay? Spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. To talk about these concepts, I'm going to use a satellite as example. This satellite is going to be the Sentinel 2. Now we are going to visit the Wikipedia website to see information about this satellite. This satellite is from European mission, European Space Agency, okay, and the program is called Copernicus, okay. Sentinel 2 is 2 satellites, as you can see here for the launch. The 2 satellites will work on opposite sides of the orbit, and the first one, Sentinel 2A, was launched on 23rd June 2015, and Sentinel 2B was launched on 7th March 2017. I decided to take this one as an example because they are pretty new, the pixel resolution is really good, and the characteristics of these satellites are really good, you know, because you can get all the information for free. You can download all the satellite images for free, and there are a lot of resources you can use to manage these kind of images, okay, from this European Space Agency, okay. Let's go to start with the spatial resolution. What is spatial resolution? Okay, I have a website here to explain this one. Is the link number 2. Let's go to open. Spatial resolution is related with the dimension of the pixels. As you can see here in this table, Sentinel 2 has 13 different bands. You know, you have band 8 and band 8A. Okay, these 13 bands, and here you can see the resolution for every band. Okay, this we have the same information here. 10 meters resolution is for the bands 2, 3, 4, and 8. For these 4 bands, we have 10 meters pixel resolution. It means we have 10 meters by 10 meters. Okay. Then we have 20 meters spatial resolution for the bands 5, 6, 7, and 8, and band 11 and band 12. Okay, and finally we have 16 meters spatial resolution for the bands 1, 9 and 10. Okay, we have the same information here, resolution. Okay, and you have to be aware, because when you make compositions for these bands, you have to be aware that sometimes if you are using, for example, band 2 and band 3, and then you want to use band 5, the spatial resolution are different. Okay, spatial resolution, it's really important, and I'm going to use this website, Image Resolution, to explain a little bit something about the resolution of the pixels. Okay, as you can see in this image, there are different squares, but every square is the same size, the same scale. Okay, but every square has different number of pixels. Okay, as much pixels you have, better resolution. Okay, and that's a very good example. You have 5 pixels by 5 pixels, you can see anything here, right? But if you have 20 by 20, the resolution it's better. And if you have 100 by 100, you can see inside the square the letter R perfectly, right? Then sometimes it's not easy to make the difference between a scale and pixel resolution, but they are different concepts. Okay, because here, as I said, this square is the same in all images. Okay, but this image has more pixels and the resolution is better than this one. Okay, another example could be this picture here. It's the same picture, the same scale, but this one has more pixels than this one. That is because this one has a better resolution. Okay, now let's go to talk about the second concept. It's going to be the spectral resolution. Okay, I have also a website to talk about this one. Okay, I don't have website because I have for radiometric resolution. But a spectral resolution, it's about how many bands has a satellite. Okay, in this case, Sentinel 2 has 13 different bands. This is a multi-spectral satellite. Okay, as much bands the satellite has, better spectral resolution. We can use, for example, this one here. This is Landsat 7 and Landsat 8. Okay, and here you have, for Landsat 7, you have 8 different bands. Okay, for Landsat 8, you have 11 different bands. Okay, that's the spectral resolution for a satellite. Other concept, it's radiometric resolution. What is radiometric resolution? Okay, I have here this link. Let's go to open the link, copy, and paste. Every pixel has information. Okay, that information is represented by the colors. How many colors can represent a pixel? What is the range? Okay, that's the radiometric resolution. For the Sentinel 2, the resolution is 12 bits for every pixel. Okay, it represents one pixel can represent 4096 different colors. That's information. Okay, and for example, if we use the Landsat, I'm going to show you again this image. Landsat satellites has 8 bytes per pixel. Okay, then it represents 1 pixel from the Landsat 7, for example, can represent 256 colors. Okay, as much colors you have, better is the information. Okay, now The last concept is going to be the temporal resolution. What is temporal resolution? Temporal resolution, it's what is the frequency you are going to get the satellite image. Okay. For example, here we have the information for Sentinel 2. Is this one, okay? Revisiting every 5 days under the same viewing angles, okay? Then we are going to have a satellite image from the same place every 5 days, okay? That's the temporal resolution, and every satellite has a different temporal resolution, okay? But in this case, it's 5 days. And now I would like to talk a little bit also what options we have for satellites. And let me explain you that the resources we have for free, it's Landsat and 7 and 8, but you have also the oldest one, Landsat 5 for example, okay? And the resolution pixel, it's 30 meters, okay? Also we have Aster. Aster has a 15 meters resolution for the pixels, and also we have a MODIS, okay? Then we can say we have 4 satellites to use the image for free. This is Landsat, Sentinel 2, Aster, and MODIS, okay? And there are also private satellites we can use, okay? We can buy the information, and these satellites, the resolution it's bigger, okay? We have Iconos, for example. It was launched in 1999, and the pixel resolution for the visible light near infrared is 4 meters. Okay, but now these satellites, it's not giving more images because the satellite doesn't work well. And also we have the Quick Bird. It was launched in 2001, and it has a panchromatic band. This band, the resolution of the pixel is 61 centimeters. That's a really good resolution. And also the resolution for a visible light and near infrared is the 2.5 meters. This satellite also stopped to give images in 2015. And the satellites we have actually with the highest resolution is the World View. We have 4 satellites, World View 1, 2, 3, and 4. And this satellite has for the 1 and 2, they have one band in the panchromatic. The resolution is half meter, and the temporal resolution is 1.7 days. And for the World View 3 and 4, the number 3 was launched 2014, and the number 4 was launched in 2016. Okay, this one has a panchromatic band with a resolution of the pixel 30 centimeters. That is crazy. It's very small resolution, you know, you can see everything with a really good detail. Okay, and the spatial resolution in this case is 1.24. You are going to have an image every 1.24 days. That's very short one. And also we have the constellation Pleiades. It is a couple of satellites, I believe. One was launched in 2011, and the other one it was 2012. And you have the temporal resolution for every day, and it has a panchromatic band of 0.5 spatial resolution and 2 meters resolution for the visible light and near infrared. Okay, now we are ready to see some images. Let's go to start with the link number 4. As I said, Sentinel 2 has a lot of different resources, and one of these resources is this website. It allows us to see satellite images without download anything. Just we can check these images on in this website. Yes, right here, Edmonton, or the area you want to investigate. Okay, and now here you can see the date. Then there are two options. You can click this button to go one day back. Then it's going to stop on the date there are satellite images. Okay, here at the top of the website you can see a bar. This is a progress bar. When the process is finished, the bar is going to be here at the end. Then let's go to talk about the images, how it works. Okay, let's go to custom. Now here there are 3 channels of visualization. This is red, green, and blue. Then if you put here I'm going to show you the spectrum, visible spectrum, just for a while. This is the visible spectrum. It's from here to here. Okay, and as you can see here, this is the bands number 2, 3, and 4. This is the visible spectrum. Not this one. Okay, then let's go to use these bands inside the channels to see a real color. Okay, then as we said, band 4, it's a red. You can see the color, that's orange. It's okay. Then band 4 has to be in the channel for red light. Then for band 3 has to be in the green channel, and band 2 has to be in the blue channel. Then with this kind of composition you are going to see a real color. Okay, this is the wavelength. That's an image for a real color. We can make zoom to see the area. Sometimes it takes longer to load all the image, then I'm going to pass the video faster. Okay, that's a real color. Then also we can click on the date here, and we can pass the years. Okay, this is nothing in 2015 because this satellite started to work in June 2015 or July. One image I saw the other day was pretty good. It was on 2017. It was August 25. It was this one. That is important because sometimes you have a lot of clouds and you can see well the picture, right? Or there are snow, things like that. Okay, the resolution for this image for the pixels is this resolution. Now we are in the channels 2, 3, and 4. As you can see here, the resolution of the pixel is 10 meters. Okay, now for example, if we go to click on the data on April, for example, I don't know why it doesn't load the dates now. Okay, March 11th. You can see now it's everything with the snow. That is not, you can see anything here. Okay, but that's the reason, because we we can modify this composition. Okay, let's go to talk now about false color. Okay, false color, it's a combination different for a true color. Every combination you do different for a true color, that's a false color. Okay, this is A43. Let's go to make this composition. 8, 4, and 3. As you know, band 8, as you can see in this image, band 8, it's near infrared, and this one it's not inside the visible light. Infrared, it's outside. Then the human eye can capture this kind of light. Okay, but when we put this band here, we represent the wavelength in this color, in red. Then it's possible to see. Okay, let's go to change here the date. I'm going to put the August 25 in 2017. This is a very popular combination for a false color because it allows us to recognize different kind of vegetation. Okay, and if you have to do a cartography related with the vegetation, or if you want to see what is if you want to compare two images, for example, one from 2014, another one from 2017, and you want to see what was the evolution of the vegetation, you can use this composition. The different colors for the red, as you can see, dark red, pink, I don't know, different kind of red. That's a different kind of vegetations. Okay, that's so popular. As you see, this map, it's very red, is because the band 8 that has this band 8 near infrared has this wavelength. Okay, and this wavelength, it's reflected by the vegetation. Okay, and the other bands could be absorbed. Okay, this band is very useful because the reflectance, it's really big. If you change the band 8 to the green channel, you are going to see this band in green color. Okay, let's go to do it now. That one is going to be band 8, and that one is going to be, let's go to use this one. At the red channel, we are going to put the blue wavelength. This one, the blue, this wavelength in this channel. And now we are going to see the band 8 in a green color, and there are a lot of reflectance for this band, and that is because the picture is predominant in a green color. Okay, but you can make the combinations you want to do it. Okay, for example, you can use these bands here. As you can see now, the resolution, it's a little bit different. The reason is because bands 11 and 12, the resolution is 20 meters. Okay, for band 3, the resolution is 10 meters, but the image it's created is for 20 meters resolution for the pixels. Okay, and these kind of compositions are going to help you to recognize different things on the surface. Okay, as you can see here, these fields has the same color. This is because they have the same characteristics. Okay, and even maybe you can recognize the industrial areas and also the urban areas, okay, with a different color, the river, okay. These combinations you can use whatever you want, but the goal is to help you to recognize elements on the surface, okay, and make the discrimination of these elements, okay. We have more tools here. You can use atmospheric correction. There are a couple different parameters. Sometimes it doesn't work, as it says here, effects are disabled for some pre-configured products, okay. Even you can modify these parameters, okay. The goal is to improve the quality of the image, to recognize the elements, and also you can download the image, the section you are watching now, and even you can free sync up for more options. That's up to you. If you click here, you are not going to see the image, and you have all these compositions already created. You have to click. For example, this one, it's very popular to see what is the stress of the vegetation, okay. This one for the moisture. This is, as you can see here, that's an equation. It's not just the combination of 3 bands. This is an equation also for this one. That kind of compositions, well, that kind of equation is going to help you to recognize the humidity, for example, or the temperature. There are different kind of index. There are a lot of index, a lot of equations you can use, or compositions, you know, in order to make an interpretation, okay. You have to play with the bands or check the equations, okay. If you are looking for something specific, maybe a specific composition is going to help you to understand what is on the surface and how you can make the cartography for the different areas, okay. Okay, that's it for this video, and the next video we are going to start to develop our skills on satellite image with quantum GIS.